No, don't. Okay, so we're looking at this rational function. R of x equals x minus 1 over x squared minus 4. Now, this is what we're going to do to begin every one of these rational function problems. Both forms are good. We need both the general form and the factored form. So since this one begins in the general form of a rational function, I'm going to go ahead and find what the factored form is as well. So, can I factor the numerator? No, so it's x minus 1. Can I factor the denominator?
Yes.
I can. It's a difference of perfect squares. So that's x plus 2 times x minus 2. Now I have both of these forms to work with, and I can use whichever one is more beneficial to me at the given time. So let's now look first for the vertical asymptotes and the holes. This is what you did during that work yesterday. So we look, do I have any common factors that cancel out between the numerator and denominator? I do not, so that means I have no holes. The vertical asymptotes happen when the denominator goes to 0. So my vertical asymptotes are at
x2 and x negative 2.
x equals negative 2 and x equals 2. Right, we're solving each one of those factors and setting them equal to 0 from the denominator. Any questions about what we've done so far? Okay, next we're going to find out where is the horizontal or oblique asymptote. So I'm looking at the first one now, right? The general form. I compared degrees. What's the degree of the numerator? 1. What's the degree of the denominator? 2. So when the degree of the numerator is less, we have a horizontal asymptote at y equals 0. Okay, and that's the 3 things that you worked on yesterday. Now there are 3 more things we're going to do each time. We're going to find out what order I want to do this in. First, let's find out, does it cross the horizontal or oblique asymptote?
How do you know?
Okay, we're going to do that in a second. Then after that, we're going to find the x-intercept. And then we're going to find the y-intercept. Okay, so when you're watching this video back, it may be a little out of order because I'm going to go to the next slide to do these things. So we may come back to this one where you can watch how we graph it in the end. But for all this work we're fixing to do, I'm going to transition to the next slide. Okay, so now we're back. We've found that it crosses our horizontal asymptote at 1. We found to have an x-intercept at 1. And we have found the y-intercept is 1/4. So I'm going to take all of this new information with the stuff that we figured out earlier, and I'm going to graph this rational equation. So first, I'm going to begin by graphing my vertical asymptotes at -2 and at 2 as dotted lines. Okay, I know that the graph cannot cross these vertical asymptotes. So I'm putting them on there as dotted lines as reference points to know I cannot cross them. Now let's take a minute to look at what happens now. Now that I know I cannot cross these lines, how many pieces have I divided my graph into? 3. 2 cuts made 3 pieces. There's everything left of this asymptote. There's everything between the 2 asymptotes. And then everything to the right of that asymptote. Okay? So there are 3 pieces, which means there will be 3 pieces to my graph. Okay? Just so we know that this all correlates together. Next, there were no holes, so I've got nothing to graph there. Next, the horizontal asymptote is at y equals 0. So I'm going to put a dotted line at the x-axis because I know that the graph cannot cross it unless I found somewhere it will cross. Okay? And I actually did find somewhere it would cross. I found at x equals 1, it's going to cross the horizontal asymptote. So I'm going to go ahead and plot that point, knowing that my graph is going to cross right there at it. Okay? The next piece of information I've been given is the x-intercept is 1. So I would plot that. Well, hey, that's the same thing, right? Right? And we talked about this being a special case of that. And then lastly, the y-intercept is at 1/4. So then I would plot that point being right here. So now I'm going to take this information and I'm going to graph my rational function. And right now there's really not a whole lot of information to be given, right? I know 2 points that are on my graph, and that's all I know. But that's all I need to know to find this middle section, okay? I already know exactly what happens between the two asymptotes, okay? I know that over here it has to be above the x-axis because it's going to go through the y-intercept here, right? And then I know right here it's going to cross the x-axis, so it's going to be below the x-axis here. Do we follow all that? Because right here it crosses. You know, it's above here and it crosses here. So your graph has to be above it and cross it like this, right? Now, the whole point of these asymptotes is the graphs follow the asymptotes. That's what they do. So as I get closer to this vertical asymptote, my graph is either going to have to go way up or way down. Well, which one's it going to be? It's going to go down, because if it went up, it would have to cross the x-axis again. Does it cross the x-axis again? It does not. So I know that this graph has to be heading down in this direction. Do you follow what I'm thinking as I'm filling that out? Now, what happens as I head left here between the asymptotes? Is the graph going to go down again? No. If it went down, it would have to have another x-intercept that does not exist. So since I know it cannot cross the x-axis, I know that this graph is going to go up towards that vertical asymptote. Okay, because the graphs always tend to the asymptotes. That means they like to get close to them. Okay, now, the next thing I need to do is figure out what happens over here when I'm left of this vertical asymptote. Okay, I see, before I ever graph, there are really two possibilities. I could be above it and then go up, or I could be below it and go down. Right? It's going to be one of those two things. It can't cross that asymptote again because there are no more x-intercepts. It's not going to cross. So to figure out which one of those two things is happening, I'm going to plug in some x value from over here and find out what the y value is. So I'm going to plug in an x value of -3. Okay, do you see how that's left? That'll tell me what happens in this portion of the graph. So I plug in -3. That will give me -3 minus 1 is -4 over -3 plus 2 times -3 minus 2. So that is -4 over -1 times -5.
Why would you plug it into that one?
I click into either one. It will not matter. So that would give me a negative over a positive. Is that what you found with your calculator as well? So get somebody to back me up. So when I plugged in -3, I got out -4/5, which means on my graph, I'm going to -3, -4/5, and plotting that point. Now that's all the information I need. I know the graph is happening below the x-axis, right? So that's all I need. I could plug in as many points as I wanted to, but I already have an idea of what this graph's going to do. It's going to be below the x-axis. It's going to come in here. It's going to curve through those points, and then it's going to head down that vertical asymptote as it tends towards the asymptotes. All right? Never crossing them. Never crossing them. Okay, so how many portions of my graph do I have filled out currently? 2. What's the third piece that I need? I need the part that is right of this asymptote. I need to know what's happening over here. So what is an x value I could plug in? I could plug in 3. Okay, so I'll let y'all do that with your calculators because I really don't have space to do it right now. If I plug in 3, I should get 2 over 5, 2/5. Okay, so 3 2/5 is on the graph. So that's right here. And now that's all the information I need to know what's happening over there. I'm going to be above the x-axis. And this graph's going to be coming down the vertical asymptote. And it's going to begin curving. And then it's going to follow the horizontal asymptote. And so this is a general form of what the graph looks like. These parts out here are not going to be exact, right? The only things that I have exact are these critical points that I found. I found some intercepts, I found where it crosses, and then I plugged in a couple points to get an idea of how the graph curves, right? I'm getting a general form of what the graph looks like. Okay, so what we're fixing to find out is, does it cross the horizontal asymptote, which is at y equals 0? Okay, this is how we do this. Of course, this is how we do this. That's why I'm fixing to show you. I've got an equation that y is equal to 0. We're going to take this information and substitute it into my equation, and I'm going to see what happens. I'm going to let the results unfold. If I come up with a valid answer, then that means it crosses at that point. If I get something that doesn't make any sense, then that means it does not cross. Okay? So we want to know, does this cross when y is equal to 0? So guess what we do? We're going to substitute 0 in for y. So this is going to be 0 equals x minus 1 over x squared minus 4. I'm literally plugging the asymptote in for y. Okay, now that we've got this set up, is there any questions about substituting in what we just did? Now I have a fraction is equal to a number. I'm going to make this a fraction equal to a fraction by putting 0 over 1. Now when I have two fractions equal, I can cross multiply, set them equal. 1 times x minus 1 is x minus 1. 0 times garbage is 0.
So x.
This gives me the equation x equals 1. So this means yes, it does cross the horizontal asymptote at 1. Okay? Yes, it does cross it at 1. Okay, so now that we found that it crosses the horizontal asymptote, the next order of business is to find any x-intercepts. So, x-intercepts happen when y is 0. Well, that sounds familiar. R of x equals x minus 1 over x squared minus 4. I plug in 0 for y. And this is x minus 1 over x squared minus 4. And you should pick up pretty quickly, this is the exact same thing I just solved, right? Well, why would that be the case?
Because that's where it crosses the horizontal.
Okay, because the x-axis is my horizontal asymptote. So if it crosses the horizontal asymptote, then it has to have an x-intercept there, right? Is the horizontal asymptote always going to be the x-axis? No, this is just a special case, okay? It's kind of weird we're starting with it, but this is a special case of that happening. So, the x-intercept is also at 1, which makes sense because that's where it crosses the horizontal asymptote. Okay, now the last thing we're going to do is find the y-intercepts. So I've got my function r of x equals x minus 1 over x plus 2, nope, wrong one, over x squared minus 4. Now how do we find the y-intercept? Plug in 0 for x. So these terms become 0. So what am I left with?
1/4.
Positive 1/4. So there is a y-intercept and it is at 1/4.
I skipped them all.
Okay, so now we've got another rational function. R of x equals x squared minus 1 over x. The first thing I'm going to do is get the factored form of this rational equation, because both of these forms are useful. Can I factor the numerator?
Yes, x plus 1, x minus 1.
Yes. Can I factor the denominator?
No.
No. So the factored form would look like this. X plus 1 times x minus 1 all over x. Now that I've got the factored form, I'm going to find, are there any vertical asymptotes or holes? So look, is there anything that cancels between numerator and denominator? No, so there are no holes. Next, I'm going to look, are there any vertical asymptotes? Okay, that would be where the bottom goes to 0. So yes, there is. When x equals 0, I have a vertical asymptote. And that's it for that part. Now the next thing we need to do, we need to find out, do I have a horizontal or oblique asymptote? Well, I've already heard y'all mumbling. Okay, we look at the degrees of the numerator and denominator. The numerator is greater by 1. Therefore, we have an oblique asymptote. And to find out where it occurs, we're going to have to do long division. So I'm going to have to go to the next page to do that. So we'll come back with an answer in just a second. So now the next thing I want to know is, does my graph cross the oblique asymptote? Does it cross, in this case, y equals x? So again, I want to go to the next page to do the scratch work to find out if it does or doesn't. Okay, the next thing we're going to do is find out what are the x-intercepts and what are the y-intercepts. Okay, so I'm going to do that again on the next page, and we'll come back with an answer in just a moment. Now we got all this information. Let's graph this. So my vertical asymptote is at x equals 0. So right here at the y-axis, I'm going to put a dotted line. That is my vertical asymptote. Okay? Right down the y-axis. There are no holes. Okay, now the next thing, there is an oblique asymptote at y equals 0. So that's the graph of a line, right? The y-intercept is 0. The slope is 1. So that means I'm going to rise 1, run 1. Rise 1, run 1. Rise 1, run 1. All right? And we can see here that the vertical asymptote is going to go right through, the oblique asymptote is going to run right through there. Okay, and I can't make it go any lower. I've got a bar. My recording bar is in the way. But I would continue that line all the way forever in both directions. Now that we've got the oblique asymptote graphed, does our graph ever cross this oblique asymptote? We found no, it does not. Okay, so then we're moving on. The x-intercepts are at -1 and at 1. So I'm going to plot those points. Okay, and then the y-intercept did not happen. There isn't one, so I can't graph that. But now let's think about this again. Remember, the vertical asymptote cuts my graph into pieces. Okay, so how many pieces does this graph have? 2. I have left of the vertical asymptote and right of the vertical asymptote. Do I know what happens left of the vertical asymptote? Yes, I do. Because I know it has to go through this point, and I know it cannot cross this oblique asymptote. So I know as I go left, I'm just going to stay right above that asymptote the entire way. All right? So going in this direction, we're going to be right above that asymptote forever. And then what's going to happen as we get closer to the vertical asymptote? The graph's going to go straight up. Right? Not straight up, but it's going to basically look like it goes straight up. Right? It's going to continue to move a little bit right, get closer and closer to the vertical asymptote. But it's not ever going to cross it. So does everybody understand? I'm now done with the left part of my graph. Everything over here is finished. left of the vertical asymptote. Now, I need to look at right of the vertical asymptote. Do I know anything about it? I do. I know it goes through this point. So that means it is beneath the oblique asymptote. Can it cross the oblique asymptote at any point? No, we found it never crosses it. So this graph is going to then stay right underneath that oblique asymptote the rest of the way up. And then what's going to happen as we get closer to this vertical asymptote? How do you know it doesn't go up?
Because it crosses the same.
You have to cross it again, exactly. So it's going to stay beneath the x-axis and it's going to head downward towards negative infinity. And so this will be the graph of the rational function.
Okay, we're done now.
Okay, so I'm dividing my function r of x equals x squared minus 1 over x. So we put the numerator inside the division box. So I get x squared. Next will be my x of the first term. I don't have one, so I need to put 0x as a placeholder. Minus 1 divided by x. Okay, since that's just one term, you don't have to put the placeholder plus 0. If you choose to, you can. It won't mess you up, but it's really not helpful because there's just one term on the outside. Now, I have an x. I want it to be an x squared. How can I make that happen? Multiply by x. X times x is x squared. I subtract these things. That gives me 0. Now I bring down the next term, which is 0x. So I have an x, and I want it to be 0x. How can I make that happen?
0.
Multiply by 0. 0 times x is 0x. That gives me nothing. Then I bring down the negative 1. How can I make the x become negative 1?
Can't.
I can't very easily, okay? So that means that this here is the equation of my line that is an oblique asymptote. It's at y equals x plus 0, which we can write simply as y equals x. Okay, so here's my equation. R of x equals x squared minus 1 over x. And I'm wanting to know, does it cross the equation y equals x, which is a line? Well, now I know what y is equal to. Y is equal to x. So instead of saying y, I'm going to say x equals x squared minus 1 over x. Substitution. All right, do we follow what I did there? I took the equation, which was y equals x, and I plugged in x for y. Now I have a fraction equal to x. So I'll put x over 1. Now I've got a fraction equal to a fraction. I cross multiply. X times x is x squared. 1 times all that is all that. Now, let's get our x's on the same side. That'll give me x squared minus x squared, which is 0 equals negative 1. That's nonsense, right? It's a false statement. So that means that it does not cross our oblique asymptote. So I found my answer. It is no, it does not cross it. So now I'm finding my x-intercepts here. So to find these x-intercepts, we would plug in 0 for y. So this will be 0 equals x plus 1 times x minus 1 all over x. Put this over 1, cross multiply. 1 times x plus 1 times x minus 1 is x plus 1 times x minus 1 equals 0 times x is 0. Now you've got two things multiplied to give you 0. That means either either x plus 1 is 0 or x minus 1 is 0. So x is negative 1 and x is 1. So I found two x-intercepts here at negative 1 and 1. Okay, now we're going to find the y-intercepts. So the y-intercept happens when x is 0. So I plug in 0 for x. That gives me 0 squared minus 1 over 0. So that's going to be negative 1 over 0, which is
None.
undefined. So that means there is not a y-intercept. Now let's think about why not. Look at where your vertical asymptote was.
Zero.
It's the vertical asymptote is at x equals 0, which is the y-axis. That's what x equals 0 is. So if that's a vertical asymptote, it makes sense there are no y-intercepts because it can't cross it.